Everybody, it's Mr. Dean here with a quick video on solving quadratics by completing the square. All right, so we've learned a little bit maybe about completing the square before, and we're going to put it to good use. Here goes. So first, how does one complete a square? Where does this come from? What's the deal with all that? Well, in number one here, we got x squared minus 10x plus c. Some number c, we don't know what it is. We're gonna make it a perfect square. So if we think about it from a geometric kind of view with the box, we have x times x gets you the x squared in the middle, or on the side there. And then the middle term, negative 10x, is going to be the combination, I've circled it in blue here, of those two like terms. So those two like terms are going to add up to negative 10x, right? And they always do. When we have this box, that one and that one kind of always are like terms and they add up. But for them to be a perfect square, the sides of a square have to be the same. And so I need that negative 10x to really be cut into two pieces, negative 5x and negative 5x. That way they're the same length, and you have a perfect square on the outside here. On the outside, that side has to be negative 5, and then this side has to be negative 5 for them to multiply times x and get what you have in that blue part. The c number now, so if we're looking for what the c needs to be for it to be a perfect square, is negative 5 times negative 5. All right, and that is 25. So the c is 25. If we're breaking it up into our factors, we have x minus 5 and then x minus 5. That's a square. It's x minus 5 squared, see? That's where it comes from. The idea comes from. So let's try it again for number 2. We have x squared plus 38x plus c. So what we do is we think about that 38x being in the combination of both these places. And so you take half of it, and that's 19x, and you put it on both sides here, 19x, 19x. And then the sides of this are going to be, of course, plus 19 and plus 19. They make a perfect square. And then the c number is 19 times 19, which I believe is 361. So our factor is x plus 19. And this time I'll put it in square. I'll just write square rather than write the same thing again. Now you might have noticed, see, we got the shortcut formula over here, and that's the way it works. To find c, we just simply take half of the middle number, cut it in half, and then square it. And this is why, from a visual point of view, why that works. So let's take a look at it in equations. So we use this to solve equations as well. That's usually where it's most useful. So this is a little interesting the way we're going to do this. We're going to take that negative 10, and we're going to find the perfect square. The perfect square is not 16. We take half of 10, negative 10, we have negative 5, and then we square that, we'll have 25. So I put that 25 in there next to, and we pushed over the 16. We pushed it out of there. Now notice I also have a negative 25. So when I added in the 25 to make this a perfect square, I had to balance that by subtracting away 25. So I can add 25 as long as I take away 25, and technically I haven't really changed the equation, not the value of the equation. And I just remember that 16 is important, and I tossed it down the end, and I made it all equal to 0. Now I grouped, so you can see the purple part together, because that is a perfect square. It's x minus 5 squared, and then I added the red parts together, and I got negative 9. So when I add 9, to try to solve this problem, I'm going to add 9 to both sides, and then I'm going to take the square root of both sides to get rid of that square. So the square root gets rid of the square. So I have now the square root getting rid of the square. I'll have x minus 5 equals the square root of 9. And the square root of 9 is, when I take the square root of the square, I have a positive and negative kind of situation. So I have positive and negative 3. And so I add 5 on both sides, like that, if you can see that. And my answer, I should have probably put it in order, but 2 and then 8. So plus 3, positive 3 plus 5 is 8, and then negative 3 plus 5 is 2. So that is your two answers to that problem. Now you also could have factored this problem from originally, and you would have gotten x minus 2, x minus 8. But sometimes we can use completing the square to help us solve unfactorable equations. So this one right here, we can't factor that at all. There's not two numbers that multiply to 22 that also add a negative 10. So completing the square to the rescue. We're going to do the same exact thing we did in that previous problem. We're going to add 25 and subtract away the 25 and not forget about the 22. And then we're going to take the first three terms that we kind of grouped together in parentheses, and we're going to say that that is x minus 5 squared. And the minus 3 comes from the last two red terms. Then we're going to add 3 on both sides. So take the square root of both sides. And the square root of 3 is not an integer, so it gets a little bit messy. Our answer really can be expressed as x equals positive root 3 plus 5 and also negative root 3 plus 5. So there's two answers kind of built into that. And I probably should make a lot of colors here, little squirrely brackets around there. So that is how to complete the square and how it's used. See you in class, everybody. Take care.